The Qidi Plus 4 is a lower cost 3D printer compared to the Bambu Lab X1C. But is it a better value? That's what we're going to find out in this video. Hi, I'm Ken of Wrist Innovations, and welcome to my Christmas edition of today's video to compare everything about the Qidi Plus 4 and the Bambu Lab X1C 3D printers, so you can make an informed decision on which one to buy if you're considering these printers. I've organized the video into chapters listed in the description that will allow you to skip around the video depending on what is important to you. First, I jump right into comparing the print quality of both printers because I think that's the most important thing to consider when making a buying decision. Next, I'll cover the key features of each printer and point out what they have in common as well as their differences. Then, I'll compare the unboxing and setup of both printers. Next, I'll review a required upgrade and a repair that I made to the Plus 4, followed by comparing the cost of both printers. Lastly, I will provide my final summary and recommendations. I just want to mention that I bought the Bambu Lab X1C with my own money. However, I want to thank Qidi for sending me the Plus 4 for my evaluation. Okay, let's get started. Comparing parts quality. I printed parts on both the Plus 4 and the X1C using PLA, PETG, the new TPU for AMS, ABS glass filled, two different versions of nylon carbon filled, and polycarbonate. I think you're going to be surprised at the results. I know this isn't a big challenge, but first I printed a benchy designed by Creative Tools in PLA on both printers. The X1C benchy turned out great, as expected. The Plus 4 benchy turned out very good. The back of the benchy looked like there was some under extrusion, but other than that, it turned out pretty well. If you have a 3D printing need, but you don't have a 3D printer, I have the solution for you. That brings me to the sponsor of today's video, PCBWay. If you are working on any prototype projects, they can help you when you need a variety of parts. They have a large amount of resources to provide all your PCB needs. Besides making PCBs, they also offer CNC machining, sheet metal fabrication, injection molding, and lots of different types of 3D printing, including metal printing. And right now, PCBWay is having their Christmas and New Year's sale offering up to 50% savings from now until January 12th, 2025. You just need to go on their website, upload your design, select the material and quantity, and you'll get an instant quote. Next, their engineering team will review and approve the quote, and as soon as PCBWay receives payment, they will manufacture the parts and ship them right to your door. Give them a try, and I think you'll be amazed at what they can do for you. I have a link in the description below. Now, back to the show. I also printed this calibration test designed by Gabox 3D on printables using PLA. For the X1C, the overhang test results indicate that there was a slight issue at 60 degrees, but it did successfully print all the way to 80 degrees. The various cylinder diameters measured 9.83 mm, 7.77 mm, 5.81 mm, and 3.81 mm versus design diameters of 10 mm, 8 mm, 6 mm, and 4 mm respectively. The various rectangle lengths measured 10.02 mm, 19.98 mm, and 29.82 mm for design lengths of 10 mm, 20 mm, and 30 mm respectively. Bridging overall looked good, and there were only a few stringers on the part. For the Plus 4, the overhang test results were very good. It did successfully print all the way to 80 degrees. At 80 degrees, it was a bit rough underneath, but this is an extreme angle anyway. The various cylinder diameters measured 9.77 mm, 7.86 mm, 5.84 mm, and 3.98 mm versus design diameters of 10 mm, 8 mm, 6 mm, and 4 mm respectively. The various rectangle lengths measured 10.03 mm, 19.95 mm, and 30.01 mm for design lengths of 10 millimeters, 20 millimeters, and 30 millimeters respectively. Bridging overall looked good, and there were little to no stringers on the +4 part. Overall, I consider both calibration parts to be essentially the same quality and accuracy. Next, I printed a business card holder designed by Chris Aero Engineering on printables using PETG. The X1C part turned out beautiful. There is an interesting pattern that the light reflects on the side of the holder, and it's on both sides. The +4 part also turned out great. It also shows the same pattern on the sides of the card holder, depending on how the light reflects. Overall, I can't tell a difference between the two parts regarding quality. This TPU is a new material from Bambu Lab that is compatible with their AMS, which is their automated material system that feeds filament into the printer. Previous TPU had to be loaded manually because it wouldn't work in the AMS. This new filament is stiffer than the normal TPU, so let's see how it prints. For the X1C, I printed 10 pieces of these tracks for a death racer that I will be building shortly. The Death Racer project is a joint effort between Michael Baddeley and Sam Prentice of the Real Sam Prentice YouTube channel. Links are in the description below. I was pleasantly surprised that there was little to no stringing with this new TPU material. The quality of the parts from the X1C turned out great. However, they are a bit stiffer than the standard TPU material. For the +4, the parts also turned out fairly good. Again, there was little to no stringing, but there were some thin spots and they were a bit rough in some areas. I think I need to do some more fine-tuning of the filament parameters to get it dialed in with the +4. Okay, now let's step up our game with a more challenging material, ABS. ABS can be a challenge because it tends to easily warp when printing because it really needs a warm environment. I decided to print this pipe wrench designed by 3dprintedhardware.com. For the X1C, the wrench turned out excellent. The main body, hook jaw, and nut all printed without any warping. For the +4, using the Qidi Studio, the standard Bambu Lab ABS filament setting uses Qidi's actively heated chamber at a setting of 55 degrees C. For the +4, the wrench had identical excellent results with no warping of any of the parts, and everything fit together perfectly. Once again, I couldn't tell a difference in the quality between the two prints. Okay, now let's get wild and crazy and print with ABS glass-filled filament. I decided to print the Death Racer's drive chain parts, including a set of track wheels, motor frame, and drive gear, and they turned out perfect. I did use a brim and support to give me the best chance of success, and there was no warping on any of the parts for either the X1C or the +4 parts, and the quality was excellent from both printers. Once again, I couldn't see a difference in the quality between the two printers. Now, do you want to get totally nuts? How about printing a nylon carbon-filled part? I specifically used Bambu Lab's PAHT CF filament, which is a composite of PA12 nylon and carbon fiber that is particularly useful in applications where the printed part may be exposed to high temperatures. Nylon is very susceptible to warping and it's very sensitive to absorbing moisture. So, as recommended, I placed a spool of the nylon CF into a filament dryer at 70 degrees C for 12 hours. Then I printed the same pipe wrench designed by 3dprintedhardware.com. First on the X1C, then on the +4. For the X1C part, the hook jaw and nut printed excellently. However, the main body started to warp at the end of the print. Now, let's see how the +4 was able to print the carbon-filled nylon pipe wrench. It actually turned out great. There was a very slight warping on the tip of the hook jaw. However, the main body and the nut printed perfectly. In the past, I have found it to be a challenge to print carbon-filled nylon because it is such a sensitive material due to the warping. Now, I performed a second nylon test, this time using Bambu Lab's PA6 nylon and carbon fiber filament. Since it was a brand new spool, I took a chance and I placed the spool directly on the printers without placing it in a filament dryer first. Then I printed the same pipe wrench design by 3dprintedhardware.com. first on the X1C, then on the Plus 4. For the X1C part, the wrench printed excellently with no warping. Now, let's see how the Plus 4 was able to print the carbon-filled PA6 nylon pipe wrench. It also turned out great, with no warping. So both wrenches from the Plus 4 and the X1C were identical with their high quality. I've never made any parts using polycarbonate, so I thought I would try this material to round out my filament tests for this video. Since it was a brand new spool, I thought I would live on the wild side, so I took a chance and placed the spool directly on the printers without placing it in a filament dryer first. Then I printed the same pipe wrench designed by 3dprintedhardware.com. First on the X1C, then on the Plus 4. For the X1C part, it printed excellently. There wasn't any warping, and the translucent wrench really turned out cool. Now let's see how the Plus 4 was able to print the polycarbonate wrench. The Plus 4 part turned out just as great as the X1C part, with no warping, and it's of the same high quality as the X1C part. So, to summarize the parts quality section of this video, based on my experience, the Plus 4 rivals the high quality printed parts from the X1C. There may be a few slight differences in print quality that could be due to me needing to further work on the fine tuning of the settings of the Plus 4 because I used all Bambu Lab filaments during my test. I really can't see any significant differences between the print quality of these two printers. Now, let's compare the main features of the Plus 4 and the X1C. The Plus 4 has a larger overall printer dimensions of 505 millimeters by 487 millimeters by 550 millimeters versus the X1C dimensions of 389 millimeters by 389 millimeters by 458 millimeters. The Plus 4 weighs 27 kilograms versus the X1C weighs 14 kilograms. The Plus 4 is heavy enough that you should consider getting some help to unbox it or to move it around. It does have some nice handles on the top that makes it easier to pick up. The Plus 4 has a larger print volume of 305 millimeters by 305 millimeters by 280 millimeters versus the X1C print volume of 256 by 256 by 256 millimeters. They are both fully enclosed Core XY printers. The Plus 4 uses 9mm wide drive belts versus the X1C uses 6mm wide drive belts. They both have a rigid internal frame. However, the X1C has metal and glass panels and doors, while the Plus 4 has plastic and glass panels and doors. The Plus 4 has a maximum hot-end temperature of 370 degrees C, while the X1C has a maximum hot-end temperature of 300 degrees C, 7 degrees lower. The Plus 4 has a maximum build plate temperature of 120 degrees, and the X1C also has a maximum build plate temperature of 100 degrees at 110 volts, however only at 100 degrees C at 220 volts. The Plus 4 has a maximum speed of 600 millimeters per second versus the X1C has a maximum speed of 500 millimeters per second. And they both have a maximum acceleration of 20,000 millimeters per second squared. They both have a filament runout sensor and a chamber fan with a carbon filter. They both have a nozzle wipe feature. The X1C has a multicolor filament / multi-material capability when using the Bambu Lab AMS, which is their automated material system. And they can take advantage of the Bambu Lab RFID tags in the Bambu filament spools that allow the AMS to recognize the color and the amount of specific materials on each spool. The Plus 4 is compatible with Qidi Tech's future version of their AMS, which they call the Qidi Box, which should be available during the first quarter of 2025. I don't know if Qidi plans to have RFID tags on their filaments in the future. Both come with an auxiliary parts cooling fan and a textured PEI build plate. The X1C works with the Bambu Lab Studio Slicer and their phone app called the Handy, while the Plus 4 works with the Qidi Studio Slicer and their phone app. Both printers print wirelessly using their slicers or the phone apps. They both have auto bed leveling, Z-axis offset, power loss recovery, and an internal LED light. The Plus 4 has a brighter LED strip, and it's easier to see inside the printer with the doors closed. It's hard to see inside the X1C even with the light on due to the low amount of light from the light bar, and due to the smoked glass door and top. They both can be set in LAN mode, which allows you to print directly to your printers via your network. You can print the following filaments on both printers: PLA, PETG, TPU, ABS, ASA, nylon, and carbon or glass-filled polymers. The Plus 4 has an actively heated chamber heater that has a maximum temperature of 65 degrees C, while the X1C does not have an actively heated chamber. There have been studies that show an actively heated chamber can reduce the warping of especially difficult materials such as nylon. Stefan of CNC Kitchen produced an excellent video on the subject of actively heated chambers, and I have included the link to his video in the description below. Both printers have a nice 5-inch color LCD touchscreens to communicate with the printer. Both have high resolution 1080p cameras. File storage memory is different between the two printers. The Plus 4 has a 32 gigabyte of an eMMC and a USB 2.0 flash drive, while the X1C has 4 gigabytes of internal memory plus the removable micro SD card. The X1C has LiDAR, which provides a filament flow calibration, first layer inspection, and spaghetti detection. However, the Plus 4 does not have this feature. Now let's talk about unboxing and the setup. Both printers have similar unboxing instructions. If you are interested in my detailed unboxing and setup of my X1C, I have a link for that video in the description below. For the Plus 4, as I mentioned earlier, it is a heavy printer, weighing 27 kilograms, so you may want to get some help lifting the printer out of the box, and also when you move it around. It does have 2 handles on top, which makes this task easier. The first accessory box has a small sample of filament, Ethernet cable, 5-inch LCD screen, lubricants, miscellaneous tools, a glue stick, door handle, and a scraper. First, install the door handle. Next, install the LCD screen by connecting the cable to the back of the screen and snapping the screen to the printer. The second accessory box contains the power cord and filament holder. Attach the power cord and plug it into an electrical outlet and turn on the printer. Follow the screen prompt by choosing your preferred language. Per the screen prompt, remove the cable ties and tool head packaging. Remove the carbon filter and remove the filter from the packing and reinstall it back into the printer. Remove the 4 screws holding the build plate to the printer frame. Then, initialize the build platform movement. Next, install the filament holder. Then, load some filament. After that, set the nozzle temperature. Then, perform the automatic Z-axis offset function, and then next, perform the input shaping function. Finally, you're ready to print your first print. Now let's talk about a required upgrade and a repair. Now we should talk about the elephant in the room, and that's the SSR design defect for the 110 volt versions of the printer that have experienced overheating and damage to the SSR board, which indicate a possible safety fire hazard. I first heard about this issue from some other YouTube curators that discovered this problem. NaziWorks and 3D Musketeers both have uploaded videos on this topic, and I provided their links in the description below. In layman's terms, as I understand the SSR issue, the original design of the SSR board was seeing excessive amps for the 110 volt versions of these printers, which caused overheating and degrading of the components of the SSR board. Here is a close-up clip from the NaziWorks video, and you can see the part has excessive damage. And you can see the part has seen excessive heat. Initially, Qidi reassured the public that there wasn't a fire hazard with the original SSR board. After what some people thought was a delayed response, on November 11, 2024, Qidi's CEO did address the problem by issuing the following statement, and here are the highlights. They designed and shipped a newly designed SSR board to all customers that had the original SSR board. They extended the warranty to the Plus 4 to an additional year. They offered any customers not comfortable with replacing the SSR boards themselves to ship the Plus 4 back to Qidi for a full refund. And lastly, they committed to implement a more rigorous testing phase before releasing new products. Now I'll briefly show you how I replaced my SSR board with the newly designed SSR board. First, remove the screws from the back panel. Then, remove the SSR board cover. Loosen the screws and remove the old SSR board. Disconnect the wires from the old SSR board. Here's a view of the old and new SSR board side by side. The new SSR board is on the left and the old SSR board is on the right. Attach wires to the new SSR board, but be very careful because the mains wires positions have changed per the photo. The old SSR board had the mains wires in the order of red, black, and yellow from top to bottom, while the new SSR board has the mains wires in the order of yellow, red, and black from top to bottom. Please see Qidi's documentation for the latest wiring diagram. Next, install the new SSR board. Attach the 2-wire cable to the new SSR board. Attach the new SSR board cover. Next, reattach the back panel and secure using all the back panel screws that were initially removed. Then install the back panel fan. Qidi also has a video on how to replace this board. So for my Plus 4, I was able to print various materials like PLA and PETG and TPU. However, when I tried to print ABS that required using the chamber heater, I received the following error message. I contacted Qidi Tech support and they were very responsive. They recommended that I try to turn on the chamber heater by setting the chamber temperature to 55 degrees C. And again, I received the same error message. So they concluded that the chamber heater fan had failed during shipping and the chamber heater was getting too hot because there wasn't any airflow across the heater. They sent me a replacement chamber heater and the fan assembly, and here's how I replaced the part. First, remove all the top frame screws. Then, detach the camera. Next, remove the top frame. Then, remove all the screws from the back panel and remove the panel. Next, remove the bottom panel. Next, remove the 3 screws from the left side panel top and left side panel back. Then remove the 3 screws from the left side panel front. Then remove 2 screws from the bottom that is holding the chamber heater assembly to the frame. Remove the left panel and then remove the chamber heater from the left panel. Disconnect the chamber heater wires from the SSR board and the motherboard. Next, route the wires from the replacement chamber heater into the frame and reattach the heater to the left panel. Reattach the left panel to the printer in the reverse order of when it was removed. Reattach the top frame to the printer. Next, reattach the camera to the top frame, followed by reattaching the chamber heater wires to the SSR board and the motherboard. There was a fair amount of dismantling of this printer to get all these wires of the chamber heater installed. However, once I reassembled everything, I was back in business because the new heater worked. This is the second out-of-box failure I've experienced with Qidi printers. When I received my X-Max 3, one of the power supplies was defective and I had to replace that. Based on my limited experience with Qidi printers, as well as other things I've read or seen online, I think Qidi has some areas of improvement to be made on the quality assurance of their products. I think they have made improvements within the last year or so. However, the issues such as the chamber heater SSR board overheating, customers' concerns with possibly coming into contact with the Q1 Pro's chamber heater, I think have caused potential customers to lose confidence with the Qidi printers. Their CEO has made a commitment to improve the robustness of their testing of their new products, so hopefully we'll see improvement in this area in the near future. Okay, let's compare the cost of the printers. At the making of this video, December of 2024, Bambu Lab is currently having an end-of-year sale on all of their printers. The Bambu Lab X1C is on sale for $1,099 and the Qidi Plus 4 is on sale for $799, a price difference of $300 versus the X1C. Now let's go to my final summary and recommendations. Overall, I'm impressed with the quality of the prints I made on the Qidi Plus 4, including prints made from ABS, nylon, and polycarbonate. And I consider the print quality to be essentially equal to the quality from the X1C. So you have to ask yourself if the additional $300 cost for the X1C is worth the different features of the two printers. Here's a brief summary of the features that are different between the printers. Number 1. The Plus 4 has a 36% larger print volume than the X1C. So if you print a lot of large prints, then the Plus 4 has the edge. Number 2, the Plus 4 has a maximum hot end temperature of 370 degrees C versus the X1C maximum temperature of 300 degrees C. So if you're focused on the higher temperature engineering materials, the Plus 4 has the edge. Number 3, the Plus 4 has a maximum speed of 600 millimeters per second versus the X1C maximum speed of 500 millimeters per second. However, in reality, I don't think this is a significant difference, at least to me, because these are theoretical speeds, and most times the design of your part and the filament materials you use dictate the speed needed to make the part. Number 4, the Plus 4 has an actively heated chamber heater, maximum temperature of 65 degrees C, while the X1C does not have an actively heated chamber. So again, if you are focused on higher temperature engineering materials, then the Plus 4 has the edge. Number 5, the X1C has multicolor, multi-material capability if the AMS is purchased. The Plus 4 won't have this capability until the first quarter of 2025. So if you need multicolor capability, the X1C definitely has the edge because they have proven technology in their AMS unit. The Plus 4 has 32 gigabyte of eMMC and the USB 2.0 flash drive memory. The X1C has 4 gigabytes of internal memory storage and a micro SD card. So for me at least, I don't think this is a significant difference between the two printers. Number 7, the X1C has LiDAR, which provides a filament flow calibration, first layer inspection, and spaghetti detection, while the Qidi Plus 4 does not have this feature. Although LiDAR is a nice-to-have feature, I don't know how to quantify the benefit of having this. You'll need to decide if this is important to you, but in any case, this would be a vote for the X1C. Number 8, the Plus 4 has an improved internal LED light versus the X1C, so it is easier to see inside the Plus 4 while printing. This is a creature comfort thing, but I really do like the Plus 4 LED, so I give the Plus 4 the edge. Number 9, let's talk about equipment product quality. I think Qidi Tech has been catching up to Bambu Lab regarding equipment product quality with their evolution of their X Max 3, then their Q1 Pro, and now most recently their Plus 4. They have addressed many design complaints that people raised with the X Max 3 and the Q1 Pro. So I think the Plus 4 is the closest Qidi has come to offer a competitive alternative to the Bambu Lab printers. I think they need to improve their quality assurance and product testing of their printers before they launch new designs, as evident in this most recent issue with the Plus 4 SSR board issue. The good news is that Qidi's CEO has recently stated they will improve in this area of their process. So it will be interesting to see how their next printer does when it is launched. Overall, as long as you are aware that things are not perfect with the Qidi Plus 4, based on everything I've covered above, then I think the Plus 4 offers several advantages over the X1C, and it could be a higher value for your money to suit your 3D printing needs. If you prefer taking the safer route based on the many satisfied customers that have been using the Bambu Lab X1C, and if higher temperature engineering materials are not your focus, then the X1C may be the better choice for you. What do you think? Which of these two printers would you buy? Let me know in the comments below. If you'd like to see my previous video titled 10 Best Upgrades to Your Bambu Lab Printer, which has over 370,000 views, that link is here. If you'd like to see my last week's video titled Bambu Lab PS1 3D Printer, Better Value Than the X1C, that link is here. Thanks for watching. Bye!